Hello everyone, we are going to solve some three variable systems now, and this is a little more intense than what we've been working on. I'm going to start off with one where I give you one of the variables and we'll just kind of practice solving the other two. So if I give you x, we're still doing substitutions here. I'm going to do 2 times negative 3 plus z equals negative 11. Everywhere I see an x, I'm plugging in negative 3. That's negative 6 plus z equals negative 11. And when you add 6 to both sides, you get z equals negative 5. And once you have z equals negative 5, now we have two of the variables. We can go ahead and get the third. So I'll say, in this third equation now, 3 times x minus 2 times, I don't know why, I'm finding y, minus 3 times z equals 22. So now I'm substituting x and z because I know x and z. And I'm using this third equation because that has all three variables. Negative 9 minus 2y plus 15 equals 22. 15 minus 9 is 6. And now I will subtract 6 on both sides. Negative 2y equals 16. So the last thing I'll do is divide by negative 2. Oops, that's 2. And 16 divided by negative 2 is negative 8. So this is not an ordered pair, there's 3 of them, so it's an ordered triple, x, y, z, and we'll put x first. So x, what do we find? X was negative 3, y was negative 8, and z was negative 5. So we're actually working in 3 space, although visualizing it can be probably more trouble than it's worth sometimes. We found all 3 of the variables, and you could go back and plug them in to check them, but we're going to actually go from scratch now. So we're going to do an entire 3 variable system, and I'm going to kind of give you some steps because if you are not organized, you are going to get lost on these. You have to be able to stay organized, you have to have good notation, or you just can't do it. You have to be able to stay organized for these to be successful. So the first thing we're going to do is pick a variable. It doesn't matter which one. You can eliminate x, y, or z, but you have to do it twice. So you have to kind of think, you have to have a little bit of strategy here, like what's going to be easy to get rid of 2 different ways. And once you get rid of that variable 2 different ways, what you will have created is a 2 variable system. Once you get down to 2 variables, we've done those. And then it kind of just unravels. Once you get one of them, you can work your way back up and solve for all 3. Okay, so we're going to have to create a 2 variable system by first eliminating one variable 2 times. Okay, so we're going to try and work smarter, and like I said, we're going to stay organized. So I'm going to label these line 1, 2, and 3 because it's really important you keep track of what you've done. And if you mess something up, if you aren't organized, you're just going to have to start the whole thing over. So at least this gives you a chance if you make a mistake. So if I want to eliminate a variable, I'll first look and see, using elimination, like I could get rid of x right there, and I could also get rid of x right there pretty easily if I were to triple this guy. So what I'm going to do first is I'm going to decide I'm getting rid of x. So I'm eliminating x, and I'll do the easiest one first. So this is line 2 and line 3, and I'm just going to screenshot this because I can. So those are the 2 lines that I'm working with, and when I do elimination, because that's how we're going to solve most of these, is using the elimination method, x goes away. Now I have 8y plus 10z, so 5 plus 3 is 8, 12 minus 2 is 10, and 73 plus 1 is 74. I have lines 1, 2, and 3. I'm going to call this line A. Sorry for the bell. That was terrifying. Okay. I'm going to call this line A. And this is the first of our 2 variable system. So I've gotten rid of one variable. I need to do it again. And like I said, I need to eliminate x again. I'm going to do line 1, which is 3x minus 2y plus 4z equals 20. And then I'm going to make this a negative 3. But remember, if you want to make that a negative 3, you have to multiply everything. So I'm going to make a little note that I'm multiplying line 2. This is like saying times 3. So negative 1 times 3 is negative 3. 5 times 3 is 15. And 12 times 3 is 36. 73 times 3 is 210 plus 9, which is 219. Okay. Now, if you'll notice, when I add those together, I get rid of x again. So now I have 15 minus 2 is 13y. 36 plus 4 is 40z. and 219 plus 20 is 239. And I'm going to call this line B. I have a two-variable system. Look, y and z, y and z. So from here, it's just like what we've been doing. You just have to think, okay, what variable can I get rid of now? And I'll look at my y's and say, well, 8 doesn't go into 13, so maybe I can look at my z's. 10 goes into 40, so what I'm going to do, I need this to be negative 40, so I want this to be negative 40 so that those cancel, but again, you have to multiply by negative 4. So I'm going to say negative 4 times line A, it's a 4, is 4 times 8, 32. Oh, negative 32. Negative 4 times 10 is negative 40z, and negative 4 times 74 is negative 296. Okay, 280 and 16, 296. Okay. Is that right? Yeah, okay. So line B, I'll say right here, and this is 13y plus 40z equals 239. Okay? All right. So what do we got here now? I have, let's see, how did I do this before? I'm going to do it the same way? I did the same way. Okay, cool. Let's add them up. And I'm going to say negative 32 and 13 is negative 19. Y goes away. And you have 296 and 239. That's negative 57. Okay, and you can use a calculator if you need help. It's easy now. Divide both sides by negative 19. And hopefully we get nice friendly numbers. Usually we do, at least to start off. 57 divided by 19 is positive 3. Great. Okay. We started the chain reaction. Once you get one of them, now you got to work your way back up. It doesn't matter if you plug it into A or B, which one looks easier. I'm thinking just line A because it's got smaller numbers. So now I'm plugging this in to line A. So 8 times 3 plus 10 times z equals 74. 24 plus 10z equals 74. Subtract 24 on both sides. 10z, 74 minus 24 is 50. And divide by 10, and you get z equals 5. Okay, I have two of them now. Now I can go back all the way to the top. I have z and I have y. I need x. Which one looks easiest to solve for x? Probably that guy right there. So I'm going to use that guy. Just so I don't have to copy it, I'm going to move it down. Okay, and we'll say, all right, I know two of these variables. I just don't know x. So I'll find x by now substituting in x plus 3 times y minus 2 times z. So what's y? Y is 3. I'll do that in a different color, looks cooler. 3, and z is 5. Great. X plus 9 minus 10 equals 1. 9 minus 10 is negative 1. Add 1 to both sides. X equals 2. So as an ordered triple, 2, 3, 5 is your solution. Okay? We first eliminated one variable two different ways. We created a two-variable system, which we can solve because we're good at that now. And once you get one of them, you get the ball rolling and you just work your way back up to get the other two. Okay? It's a lot of steps, but the nice thing is they all kind of feel the same. Once you get used to it, these are pretty good. Let's try another one. What do I want to get rid of first? Usually I look to see, can something go away right away? I'm thinking I want to get rid of y. I'll probably do it with lines 2 and 3 the first time, and then maybe I'll pick maybe 1 and 3 because I can just triple this guy. So for 1 and 3, I have 4x minus 3y plus 5z equals negative 19, and negative 2x plus, wait, I wanted to do 2 and 3. Why did I do that? Okay, try that again. I'm trying to get rid of y. Let's do these two. Okay, this is the easiest. Let's do this one first. 2 and 3. Y goes away. That's the whole point. And now I have 3 minus 2 is 1x, and negative 8 and 3 make negative 5z, and 13 and negative 21 make negative 8. I'm going to call that line A. So now that we have line A, we're going to eliminate y again, and that's what I was doing before. I'll take line 1, and then I'll take line 3, but I need that to be a 3, so I need to multiply by 3. Technical difficulties, let's go back to what we're doing. I'm going to make that a 3, so I will triple line 3. Okay, so instead of negative 2, now it's negative 6, and instead of 1, it's going to be positive 3, and instead of 3, it's 9, and 13 times 3 is 39. Okay, now I can eliminate y. Negative 6 and 4 make negative 2x. 9 plus 5 is 14z. And 39 minus 19 is 20. This will be called line B. Notice I have xz, xz, two variable system. Let's go. What can I get rid of? Let's see. X is 1 and 2. That's probably easy. If I make that a 2, so 2 times line A, 2x minus 10z equals negative 16. Line B, negative 2x plus 14z equals 20. Okay, I'm just copying line B. And now, x goes away. 14 minus 10 is 4, and 20 minus 16 is also 4, so that must mean that z equals 1. When you divide both sides by 4, you get z equals 1. Now we can go back and we can plug 1 in. You can either do it here or you can do it here. I'm thinking this is probably easier, so I'm going to pick line A. I'm going to say x minus 5 times 1. X minus 5 equals negative 8. Add 5 to both sides. X equals negative 3. One more time. I'm looking for y, so which one's easy to solve for y? Probably this guy. Okay. If I have a 1y, that's the one I'm going to pick. So let's plug in what we know. Negative 2, I know x, plus y, plus 3, I know z, equals 13. What's x? X is negative 3, z is 1. So 6 plus y plus 3 equals 13. 9 plus y equals 13. These are like terms. What happens there? There you go. 6 plus 3 is 9. And then last thing, divide by 9. Or I'm sorry, not divide, subtract 9, and you get 4. So as an order triple, x, y, z. Okay? So negative 3, 4, 1. Most of the problems you work through should pretty much feel like that. Now, the next two we do are going to be a little weird, and I just want to show you the weird stuff that can happen. Most of the problems, though, will kind of work like that, okay? So the next two, something's weird is going to happen. I'll just tell you right now, okay? Let's play the same game. I'm going to get rid of, it looks like I could do 1 and 3 and get rid of y. So anytime I have one that's already set up, I usually take the win. Here's 1, here's 3, okay. Not always, but most of the time this seems to be the way to go. 1 and 3. Now we will eliminate y. Bye-bye. 3 plus 2 is 5x. 10 minus 3 is 7z. And 15 and 14 make 29. This will be called line A. We got to get rid of y again. It doesn't really matter how we do this. Let's pick those two, but I have to double this one. So I'll take line 1. That's fine. And then I need to double line 2. So 2 times line 2. This is line 1. Double line 2. 2x. Oh, make it negative as well. So it'll be negative 2x minus, I'm multiplying by negative 2. So negative 2x, negative 4y, negative 10z, negative 4 times negative 2 is positive 8. What is going on here? You might have noticed this thing is setting up for, well, y went away. Great. That's what I was trying to do. But x went away and z went away. And on the left side, I have 0. And on the right side, I have 22. Now, when this happens in a two-variable system, it's the same thing. You're like, no, it doesn't. 0 does not equal 22. Okay? So, if you're working in 3 dimensions, it could be that the planes are parallel. It could be that 2 of the 3 planes are parallel. There's several different ways that you can get no solutions. It could be all 3 planes are parallel. At the end of the day, what's important that you realize is that when you have something like this, a false statement with no variables, there is no solution to this, okay? We are not going to be able to continue because 0 does not equal 22, okay? If you ever end up with a false statement, that means there's no solution. And in 3 dimensions, it's more complicated than just a parallel. There's several ways that can happen, so we're just going to say there's no solution, okay? There's one more weird thing that can happen. We'll do the same thing. I'll take the first 2 lines because it looks set up. And actually, I could probably take the second 2 lines because it also looks set up. So maybe this will be quick. Okay, this is 1 and 2, and this is 2 and 3. And what I'm looking at is the y's are opposites for both of these. Okay, so just because I saw plus 2 and minus 2, that's nice. So I did the first 2 and the second 2. 2x minus 2y 4z. That's the first 2. Yeah, that's the second 2. Okay, so y goes away. 6x plus 12z equals 18. And here, 8x plus 16z equals 24. That's line A. That's line B. Now, this system's kind of annoying because 6 doesn't go into 8 and 12 doesn't go into 16, so we need to mess with both of them. We need to think of a common multiple. I'll probably do the x's. So 6 and 8, what's a common multiple? 6, 12, 18, 24. I'm going to multiply line A by 4. So 6 times 4 is 24. 12 times 4 is 48. And 18 times 4 is 72. This guy, I want this to be negative 24, so I'm going to multiply by negative 3, negative 24x minus, 48z. Oh, that's supposed to be a z. Right here is a z. Z. And negative 3 times 24 is negative 72. Oh no. Weird again, but for a different reason. Bye. 0 equals 0. It sure does. Yeah, that's called the identity, or the reflexive identity, right? It equals itself. Like you look in a mirror. 0 does equal 0, and that's always true, and there's no variables. So, like we said before, we have the no solutions. Well, this is one where we have infinitely many solutions. And that can happen for several reasons when you're talking about planes. It could be that they're the same plane 3 times, or it could be that they're one plane that's rotated around a line, and so the answer is all of the order triples on the line in 3 space. Again, we're not going to get too much into the graphing thing, but it is cool to look at sometimes. So, sometimes you will have a false statement, that means no solution. Sometimes you will have a true statement, that means infinitely many solutions, but most of the time you should have one order triple. Again, these are long, difficult problems, but once you get the hang of it, they all kind of start to flow and they feel the same. So, get the practice in, smash that like button, and hit that subscribe button.